All right, now that we've used the serial.read function to read in alphabetic characters and numeric characters, let's see how we can translate those ASCII values into numeric values. This is the sketch we ended up with at the end of part 2. All right, if I just open up the serial monitor again, it's already uploaded on my board. We saw that with this sketch, we're only reading information when it's available. We saw that if I, if I type in a 3 and hit the enter key, then what we receive has a decimal value of 51. Right? I had the no line ending then turned on, so it only transmitted the one character. We're seeing the character then we receive simply because the println is echoing this information back out to the serial monitor. Right? How do we turn that 3 then into a numeric 3, that character 3, the 51? When we looked at the ASCII table, then we saw that 0 through 9 are all here together in the ASCII table. 0 is a 48. Right? 3 is a 51. If I were to subtract 48 from 51, I actually get the number 3. The way we work with character data is that we say, well, read byte is this, but now what if we were to print out serial.print? What if we say, what's the value of read byte, right, minus the character 0? Print that out. All right, so here I'll say read byte minus the character 0. Let's upload that. All right, so now let's type in that 3, hit the send key. So the first thing, when we just print out read byte, we see that's 51. But the result of read byte minus the character 0 is the number 3. In order to then convert these ASCII character values back to their single-digit numeric values, we simply subtract out 0, or 48. Right? I can show you here if we were to just subtract out 48 and upload that, we'll get the very same result. So here's my 3, hit the enter key. There's our value. Sorry, I didn't change this here. Should change this to 48 to reflect what we're doing. That's just the strings printed out. And here, 3, hit the enter key. All right, we get the value of 3. All right, so let's say then that we were going to use these numbers to do something like control a blink rate. Let's then create a value. So blink rate. I'm going to set the blink rate to a default of 100, right? And let's write a little function called blink. And remember then, in order to get an LED to blink, I'm using a global variable. In order to get an LED to blink, we call the digital write function. And we need an LED. We're going to use the one that's attached to the board, so that's pin 13 on my board, or we can use the mnemonic LED built in. Right? We send that high, it turns it on. If we delay, so our delay then is going to be the variable I just called blink rate here. Right? In milliseconds, and then if I turn it off, I call digital write again, using that built-in LED, low turns it off. I want to leave it off for that same amount of time. Right. So now, if I call the blink function at the start or end of loop, right, it doesn't matter which one, I can get that LED to blink. The other thing we need to do is we need to go ahead and set up the pin mode. All right, so when we're using digital write, we want to treat that pin, we want to write to that pin, digital write writes to the pin. I need to specify which pin I want to put into output mode. All right. So now I've set my digital pin into output mode. Blink then, LED built-in is the one that's automatically attached on your board, the built-in one. On my board, it's 13. All right, if I were to run this now, if my blink rate's 100, so 100 milliseconds, it's going to blink, right? It's going to turn on for 100 milliseconds, off for 100 milliseconds. All right, even if then I don't get any other data in here. All right, I can upload that much, and blink was not declared in this scope. Oh, it's trying. Sorry, I wrote it inside the, accidentally wrote it inside the loop function. Not the thing to do. All right, we don't write functions within functions. All right, if you do this and upload this to your board, all right, what you're going to see is that your built-in LED is blinking at a rate of on 100 milliseconds, off 100 milliseconds. Right, no matter whether or not you you send any information in here. Once again, if I go ahead and hit 3, hit the enter key, right, I now get a number of 3. We just added this behavior of blinking. What I would like to do now is I'd like to take this number that's coming in and use it to control the blink rate. What we're going to say is, right, read a single numeric digit and right, and use it to control blink rate. What I could do then is I could say my blink rate is going to be equal to, well, that could be my read byte, and then if I subtract out the 48 or the 0, right, then I'll get a value of blink rate will be 3. Let's just go ahead and show that again. That blink rate and here we're just going to then print out blink rate. Again, we'll upload this. We're going to use that default blink rate of 100. And now if I type in the 3 and hit the enter key, all right, we can see that read byte is still at 51. Blink rate has a value of 3 in it. Right? Now, what you're probably getting on your board at this point, if you're using the value of 3, this means on for 3 milliseconds, off for 3 milliseconds. It probably looks like your LED is constantly on. We don't want to use a blink rate that low, but what if we just went ahead and said, multiply blink rate by 100 so we can see its effect. All right, so we'll just treat this, then the single digits we'll just treat as being 1 should give us 100, 2 should give us 200, 3 should give us 300. So if we can say blink rate equal blink rate times 100, Let's upload that. So we have that default value of 100 going on a 3, hit the enter key. Right now blink rate's 300, so that should be a slower blink rate than that 100 milliseconds. Similarly, if I type a 5 and hit the enter key, well, now our blink rate's 500 milliseconds. If we say 9, that gives us 900. Right, now what happens if I say, oh, let's make it 12? Right, 12 isn't going to give us 12. What 12 gives us first is that character of 1. So what it does is this serial.available greater than 0. Well, that's true after I typed the 12. It reads in 1 byte. So the first byte it read in was that number 1, right, which was the 49. 49 minus the 48 gave us a 1. 1 times 100 gave us the value of 100. That updated then that blink rate. And then when we loop back around, well, there was still serial data available, the number 2. We read in the number 2. Right, that went ahead and then changed the blink rate to 200. So just because I type multiple digits here, right, remember serial read, the way we've written this is only handling 1 at a time. Multiplying that by 100 then to give us a blink rate in terms of hundreds of milliseconds. Now this is all working, right, as long as I type 1 digit, right, 1 numeric character. But what happens when I type in a non-numeric character, right, the small case a? Well, now my blink rate is 4900. That's because the small case a is a 97. 97 minus 48 is 49. 49 times 100 is 4900. We only want to work with numeric digits, right? We want to read a single numeric digit. What we should do is after we read this in, we want to verify read byte is a numeric character, right? And there's a simple function called isDigit. So if we call isDigit and we pass it read byte, and isDigit returns true, then whenever then we've got a numeric digit, and only in that case do we want to update our blink rate and display the new. Otherwise, we'll simply ignore the non-numeric ones. Let's upload this. All right, so we've got our default. If I type in the 3 and hit the enter key, we update to 300. But now if I type the character A and hit the enter key, notice, right, we simply ignored it. We didn't print out any of that information. We didn't update the blink rate. We're still going with the same blink rate. 5 still gets me that. 4 and a 6 is going to get me, well, first the blink rate of 400 first time through the loop, then the 6 the second time through the loop. So now we've got a pretty good working program that takes 1 digit and turns it into a numeric value that we're multiplying by 100 to get the blink rate. In our next video, we'll take a look at how we then work with multiple digit inputs.